Hi Diksha Didi.
Hi, good afternoon.
Good afternoon. So today we are gonna be starting with the bitwise operators that we left yesterday, and we will start with the correct explanation of and equals to and or equals to.
Okay.
Right. So first of all, to actually learn the bitwise operators, we need to understand how to convert a bitwise number into a normal integer. So, for example, let's take the number 0110. So, now this is a binary number with 4 digits. So, to convert this, what we have to do, what we have to start from the right hand side. So, the rightmost digit is 0, right? So, we'll say 0 into, and then we have to say 2 raised to the power 0, that is equals to 0. Then then we'll ignore this digit and come to the next digit from the right hand side. So now the next digit is 1, so we'll say 1 into 2 raised to the power 1. So these 2 raised to the powers will be 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, and it will these 2 raised to the powers will go on till the number of digits you have. So like for example, we have right now 4 digits in this binary number. So we'll have 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, and 2 raised to the power 3. And we'll multiply with these values with the bits starting from the right hand side. So the rightmost was 0, so we did 0 into 2 raised to the power 0, that was 0. Then we have 1, so 1 into 2 raised to the power 1, that is 2. Then we have 1, so 1 into 2 raised to power 2, that is 4. And then 0, that is 0 into 2 raised to power 3, that is equal to 0. So now if we add all of these digits like 0 plus 2 plus 4 plus 0, so we get 6. So now, sorry, so 0110 is equivalent to 6. So is the
Okay.
conversion from binary to integers clear?
Yeah, I've actually done the conversion of binary to integers and
Oh,
integer to binary.
oh, all right, great. So now we are gonna see the operators that we can use on the binary numbers. So for example, we have a variable a that whose value is 10, and we have b whose value is 3. So the binary number for 10 is 1010, and the binary number for 3 is 0011. So now what and equals will see, it will see the first digit and the second digit, right? So it will do 1010 and 0011, that is equals to 0010. So the how is it equals to 0010? It will see that this the leftmost digit of 10 is 1, and the leftmost of 3 is 0. So when both of them are 1, then it will put 1 over here. When one of them is 1 and another is 0, then it will put 0 over here. And when both of them are 0, then it will put 0. So over here we have 1 and 0. So 1 and 0 will put 0 in our resulting number. Then we have 0 and 0, so that will also over here we'll get 0. Then we have 1 and 1. So 1 and 1 will put 1, and 0 and 1 will put 0. So we have 0010, and 0010 is the binary representation of number 2. So now a and equals to b will set the value of a to b, a to 2. Now when I try to print, I'll do C out, and we'll say a, right? So we'll now show the value of a. So when I run this, so we'll get 2. So is and equals to clear?
Okay.
That
Yeah.
okay. So now I'll just comment this code with the shortcut that we learned in the first class, and we'll uncomment this code. So Nanu, now we have a, Nanu, now we have a equals to 10 and b equals to 3. So we know the binary representation of 10 and 3. So now we are using the or equals to operator. So or equals to will check if both the digits have 1, then it will put 1. If one of the digits is 1, then also it will put 1. So when both the digits will be 0, then only it will put 0. So for example, 1 0. Now one of the bits is 1, so it will put 1 in the resulting number. Then we get 0 0, so now 0 and 0 will put 0. Next we have 1 and 1, so 1 and 1 will put 1, and then 0 and 1 will also put 1. So we get 1 0 1 1. That is the binary representation of 11.
Okay.
So now we have the caret equals to. So caret sign is also will also do a binary operation. It's also a bitwise operator. So what the caret sign does, when when it finds two equal bits, then it will put 0. So when it finds 1 and 1 and it finds 0 and 0, then it will put 0. But when it finds 1 and 0 and 0 and 1, then it will put 1. So for example, we have 1 0 1 0 and we have 0 0 1 1. So we get 1 0 over here, so it will put 1. We have 0 0, so it will put 0. We have 1 1, so it will put 0. And then we have 0 1, so it will put 1. So the equal, when we have two like bits, then it will put 0, and when we have unlike bits, then it will put 1. So 1 0 0 1 is the binary representation of 9.
Okay.
Alright. So next we have the left shift operator. So what the left shift operator will do, like for example, we have 5. Its binary representation is 0 1 0 1. Now we perform the left shift and we say shift the binary digits by 2 to the left side. So what will happen when you're doing left shift, these arrows show where the binary number will go. So like we have 0 1 0 1, so this is shifted to the left, and in the end two zeros are added, so we get 0 1 0 1 0 0. So that is the binary representation of 20. So it will
Okay.
shift the binary number to the left and then add the number of zeros we specify over here. So we specified it to add, we told it to add two zeros. So it shifted the binary representation to the left and added two zeros. Similarly, we have the right shift, but the difference is that it will shift the binary number to the right, so it will shift the binary number to the right and add two zeros in front.
Hmm.
So when we are doing we have 20, which is 0 1 0 1 0 0. So when we shift it to the right, then it will be so the two digits over here are removed, right? So the 0 0 are removed from the end. Whenever we are shifting to the right and we are saying 2, so the end two digits will be removed, right, and 0 0 will be added to the starting of the number. So two digits from the end are removed from 20's binary representation and 0 0 is added to the start. So now A is 5, that is 0 0 0 1 0 1 in binary.
Okay.
Right. So these were our bitwise operators. You will very rarely use them in programming, but these will still come in handy when doing math operations. So after these operators, we are now on strings. So strings we have already seen in brief, but now we'll learn methods and how to access strings and how to change strings. So we'll learn operations on strings. So strings are used for storing text. Strings basic use is to store text. A string variable contains a collection of characters surrounded by double quotes. So it contains a collection of characters surrounded by double quotes. So for example, you have string greeting whose value is hello, right? So this hello is always surrounded in double quotes. You cannot use single quotes. For char, single quotes is used. So to use strings, you must include an additional header file in the source code, the string library. So now to use a basic string, you can say string, but if you want to perform operations on the string, you'll have to include the string library. So we can say hashtag include include oh sorry include string string. So now this will include the string library. But now you may be wondering, why are we giving it before using namespace standard? Because IOStream and string both have a standard namespace in them. So we only want to take out the methods that are there in the standard namespace of the string library. That's why we are giving it above using namespace standard. If we give it after using namespace standard, then what would have been happening? You it would have imported everything from string, and to use the string methods we would have to say standard, and then after that we would have been able to write the method's name, like we saw in IOStream when omitting the using namespace standard. So we should not omit the using namespace standard for our own ease.
Okay.
Alright. So this using namespace standard will apply to both IOStream and the string library. So to use strings you must include, okay, so we have seen this. And I see an exercise over here. So did you do the exercises of the previous chapter?
Yeah, I did. Like
Oh,
four, but the last two were left.
oh, alright. No problem. So next
Do we have to use hashtag before include?
yeah, we have to use hashtag before include. In Python, hashtag
Okay.
is used for commenting, but in this it is used to include libraries.
Okay.
Alright, so we have string concatenation. So we saw the plus operator in the operators chapter that was used to add two numbers, but it can also be used to concatenate two strings, meaning it can join two strings together. That is called concatenation. So the plus operator can be used between strings to add them together to make a new string. This is called concatenation. So for example, we have the string first, we have the first name variable John, and then we have the last name variable Doe. So we can use the plus operator to add the two names and store that in full name. So now when we print full name, we'll get the full name John Doe, and John Doe will be in one single string. So let's just let's should I delete this code, or I send you this code for reference?
Now you can delete it.
All right. So we'll just remove this. We'll just keep the comment over here, and over here you can say string first. All right. First name is equals to John, and note it will we have to add a space after John so that there's a space between John and Doe, right? uh, Otherwise
Okay.
they would have been stuck together, and it the full name would not have been that beautiful. So yeah,
Okay.
string last name Doe. What we could have also done, instead of adding a space after John, we could have added a space before Doe, right? And it would have been the same thing. And we'll just correct the uh, name. Yeah. So after string first name and string last name, we can say string full name is equals to first name plus last name, and this will concatenate the two strings together and store it in full name. So next we can just show the full name. So we get John Doe. Alright. So in the example above, we added a space after the first name to create a space between John and Doe on output. However, you could also add a space with quotes. It's saying that when concatenating, instead of adding a space over here before Doe or after John, what we could have said, we could have concatenated first name, then we could have concatenated a space character, and then we could have concatenated the last name, so it would bring the same result.
Okay.
And because this space is a single character, we could have also said single quotes, and it would have concatenated the space single character. If we wanted to concatenate two spaces, then we only could use double quotes. But when we have to concatenate a single space, then we can also use the single quotes. So next, all right, so this is an example. To also if you want to concatenate strings together, you can also use the append function that is part of the string library. So the string library we included, now this will come in handy, as we can use the append function of the string library. So what we could have said, we could have given a space after this, and we could have said the syntax is first name, so the string that you want, sorry, so the string that you want for to occur first, dot append last name. So what will happen, first name will come first. Now after first name, the last name will be appended, and now this append function will return us the result that will be stored in full name, and it will give us the same output. So now the append function is part of the string library. If we hadn't imported the string library, the append function wouldn't have existed, and it would have given an error. Alright, so we are not getting an error because I think the append function is not part of the string library itself. It's part so I think the length and all of these functions are part of a string library, but mostly in other languages all the functions are part of the string library, but in this case append was not part of the string library. But when you want to use functions on strings, it's suggested to always import the string library so that you don't face an error whenever you want to use a specific function. So append
Okay.
was a predefined function of the string data type that is already there, and it is also a part of the string data type that is being included from the string library. So append is both predefined and a part of the string library. Next we have numbers and strings. So there's a warning, C++ use the plus operator for both addition and concatenation. Numbers are added and strings are concatenated. So when we have two numbers, they can be added together using the plus operator. But when we have two numbers in quotes, right, so we have 10 and 20 in string quotes, so when we add them, these will be concatenated, so we'll get 10 20 together, right? And when we try to concatenate a string and a number, then it will give us an error like it is in Python. This is very similar to Python, right?
Got it.
So we have, next we are on string length. So basically there's a length function of each string. So when you call the length function on the string, then you'll get the length of that string, right? Similarly you have the size function, that is an alias, that's an alias of the length function, and you could either use length or size, it's up to you. It will give you the size of your string. So for example, we have the string full name. So if we print this full name dot length, if we print the if we see out the full name dot length, so we'll get the length of the full name, that is 8 characters. If we had said size, so size would also do the same thing. So it's up to you which method you want to use. All right.
Okay. Hmm.
So next we are on accessing strings. Till now we have been working on the full string, and we are performing operation on the full string. What if you want to access specific characters of the string? So you will use indexing for that. So for example, I want to access the first letter of my full name. So what I'll do, I'll say full name, I'll give brackets, right? So brackets will be used for your indexing. So indexing can be performed on arrays and on strings. So when you are saying a 0, indexing starts from 0. So this is saying access the 0th character of the string, and the 0th character, it means the 0th index character. So 0th index character is the first character, so it will bring J. When we say 1, it will bring O. So it's saying the character on the first index, and the first index is uh, is the second character, so that is O. So indexing starts from 0.
Okay.
So this is how you can access specific characters of your string. So using 1, you can access the second character, and you can also change string characters. So if I could have said I want John, I could have instead of C out over here, I could have said full name 0. So the 0th character of the full name, change it to H, and we'll have to give it in quotes. Right, so we are saying all right, so we are saying that change the first character of your full name to H, so it will be Hondo. So we'll get Hondo. So we are not showing the full name, so if we see out the full name, we'll get Hondo. So it has changed the first character of our string.
Okay.
Right. So next we are on special characters. So this will explain the escape sequences that are there in this. So for example, in the string we want double quotes, right? So uh, if I want to create a string, so I'll just delete all of this code. I'll say name, or we'll say uh, text is I am the so-called Viking, and I'll say Viking in quotes. I want Viking in quotes. So now what is happening over here? This double quote will close the full string, right? So this double quote is closing the string. Then Viking is outside of the strings, and then it is opening a new. Sorry about that. So now it's opening a new string, and so this string and this string are two different strings, and Viking is outside of both the strings. So how can we solve this? Using the escape sequence, using the backslash. So we'll add the backslash before both the quotes, and this will escape. This will tell the string that we want quotes inside of the string, and we don't want to close the string. So it will if we see out text, so it will give us quotes in the string. Is this clear?
Yeah.
So backslash will be used to escape characters like double quote, single quote, etc. But what if you want to show a backslash in your string itself? Then what will you do? So you'll say backslash, and that will add a single backslash in your string. So it will escape the backslash. So this is all the examples, and we have the new line that we saw for the before in the syntax chapter, I believe, and then we have the tab. So tab is, I think, 4 spaces, or it is 2 spaces in this. So when we say \t, then it will add a tab, meaning it's not just a single space. It's a tab is a collection of spaces. So that many spaces, what how the number of spaces that are there in tab, that many spaces will be added. Is this clear?
Yeah.
All right. Next we have user input streams. So this is a very important chapter to understand. So it is possible to use the extraction operator on cin to display the string entered by the user. So if we want the first name of the user, what we'll say cin and use the extract extraction operator, and we'll say save it in. So we'll say we'll create a variable string x, and whatever we get from cin, we'll save it in x, right? And just to give context to the input, we'll see out, type in your full name. So now this will ask the user for his full name, and it will then whatever the full name the user enters, it will be saved in X, and then we can see out the your full name is X. So this should show our full name, right? We expect it to show the full name that we entered. So we'll say type in your full name, Saion Gupta. But you see, your full name is Saion. It is not showing Gupta, right? Why? Because cin considers the space character to be the terminating operator, terminating character. Like after cin, after we enter something, we add enter to terminate the cin. Similarly, the space character is a terminating character for our cin method. So once we enter the space, it knows after this whatever is entered, it does not have to consider. So after the space, it ignores all the text after the space character. And how can we basically overcome that? What we So it is giving an example over here. So how can we overcome that? Instead of using normal cin, what we can do, we can say get line. So I believe yes. So get line, and we can say cin and x. So what this is doing, it is saying to take the input and save it in x, but whatever is in the line of the cin, right? So from wherever the cin is starting till the end, right, till it does the user does not press enter, till then consider the text and then save in x. So from example it will be more clear. So I write Saion and Gupta. So now after the space the cin is ignoring, but getLine is saying that from wherever the cin started, that is from here the cin started till the end, till it does not reach the enter character, till then get the line and then save it in x. So now Saion Gupta will be saved in x. So in simple words,
Okay.
it will take the full input you'll take the full input using getLine.
Okay.
Next we have omitting namespace. So it is telling us that when omitting namespace, you will have the standard namespace, you will have to add this standard you'll have to add this before every method. So you'll have to say standard string, you'll have to use standard before cout, and then only you will be able to use your methods from iostream and your methods from the string library. All right.
Yeah.
So we have already seen this in the iostream chapter, in the output chapter, And now we are on the math chapter. So this will tell us about some functions that are there, which we can use to perform mathematical calculations. So C++ has many functions that allow you to perform mathematical tasks on numbers. So max and min are built-in functions that are already there in C++, right? But to use more functions and more advanced functions, you'll have to import a library CMath, right? So let's see. Let's first try the max and min. So you give a lot of values to max and min, and the methods will tell which is the lowest number and which is the highest number. So max will tell which is the highest number, and min will tell which is the lowest number. So if I say see out the max between 5 and 10, so which is the maximum number between 5 and 10, print that. So we get 10 because 10 is greater than 5, so it is telling us 10. But if we want to check what is the minimum number between 5 and 10, so which is the smallest number between 5 and 10, so it is 5. And you can give as many arguments as you want. So for example 9 also, and then you can say 18 also. So it's showing us an error. Oh no, I don't think we'll get an error, but we are getting an error that it's saying no matching function for call to min. So I believe that in many languages, like in Python also, you have max and min, in which it can take as many arguments as you want. But in this C++ language, you have a min and max which can take in only 2 arguments. So in
Okay.
Python also you have the math library which you can use to take out max and min.
Hmm.
So we have the CMath header. For this, I believe you do not have to use the standard namespace, or you do have to use the standard namespace. Alright, so you will give this also before using namespace standard. So now using namespace standard will be applied on IOStream, string, and CMath. So it will apply on IOStream, string, and CMath, right? So you will now all the methods in the namespace standard in the CMath library will also be imported in this file. So there are many methods like square root, round, log, and there are a lot of methods. So we'll use some methods that are important like square root. So square root we can use. So you can say sqrt is for square root of 64. So we'll get 8, right? We have round method which will round any double number or floating point number, like round 2.25. So this will round it to 2 because 0.25 is closer to 2. If he said 2.75, so it will round off and say 3 because 0.75 is closer to 3. 2.75 is closer to 3. And we have the log function, and I'm not actually taught what the log function does, so but you can use it. Then you have the absolute value, so that will give us the absolute value of a number. So if I say abs 2, so it will give us 2. If I say absolute value of minus 2, then it will give us 2. So any negative number, the absolute abs function converts to positive. Then we have a cos. I think these are trigonometric functions that we are not taught, but similar to sqrt, that was square root, we have cbrt, that is cube root. So we have cbrt. So if we say 225, oh, so we get the cube root of 225 to be a floating point number, right? If we say 400,
uh,
we get the cube root of 400, that is 7.38 3806. If we say 8, we'll get 2. Alright. Next we have the seal. So unlike round, any decimal point number, it will round up. So if we have, sorry about that, if we have seal 2.25, then instead of rounding it to the closest integer, it will round it up to the closest integer. So rounding it up to the closest integer gives us 3. Then
okay.
we have the exponent function, uh, using which you can so you have many functions that you can explore. You have the power function that can say x to the power of y, right? So and you have many trigonometric functions also, right? So these this math library will come in handy when developing complex applications. Now we are on booleans chapter. Is everything clear? Or
Yeah.
all right?
No, that's clear.
Yeah. So C++ booleans. Very often in programming, you will need a data type that can only have one of two values, like yes or no, on or off, and true or false. For this, C++ has a bool data type which can take the value true, that is 1, and false, that is 0. So boolean values, a boolean variable is declared with the bool keyword and can only take the values true or false. We have already learned about booleans before, right, in the variables and the data types chapter, right? So so it's saying from the above example, you can read that a true value returns 1 and the false value returns 0. However, it is more common to return a boolean value by comparing values and variables. So we'll understand the statement over here in this page, that is boolean expressions, right? So a boolean expression returns a boolean value that is either 1 that represents true or 0 that is false. This is useful to build logic and find answers, right? So you can use these in if statements, um, in conditions, right? You can use these in while loops that we will learn in the further chapters. So you can use the comparison
Okay.
operator such as greater than operator to find out if an expression is true or false. So if we say x is equals to 10, y equals to 9, and we say x is greater than y, so we know that it will give us true. But on the console, we'll get 1, that is a representation of true. And we already saw this example before. Like int x equals to 10, int y equals to 9, cout x greater than y. So this will give us 1, that is true. Alright. Or even
Yeah.
easier, we could have, instead of creating the variables, we could have directly checked 10 greater than 9 and it would have given us true or false. In the examples below, we'll use the equals to operator. So you can also use the equals to operator. So whenever using the comparison operators that we learned in the operators chapter, you'll always get a result that is either true or false. Next, we have a real life example. Let's think of a real life example where we need to find out if a person is old enough to vote. So in the example, we use greater than equals to comparison operator to find out if the age 25 is greater than or equals to the voting age limit, which is set to 18. So this will check if a person is eligible to vote, right? And there is an if statement example that we will see in the if else chapter. And this was it for this class, as the meeting is about to end. I hope you liked the class, and we will continue tomorrow on the same timings.
Okay. Thank you.
Welcome.
Bye.